smallest one, that is 6 between I and G. So I and G, if we choose this I and G, so this graph will be a closed graph, or that is called a cycle. Cycle. One cycle will be. So that is why we have to ignore this Ig, the age between Ig, that is 6, because of their habit. If we choose this, so one closed graph will be occur. This will not the tree anymore. This will be not a tree anymore. So that is why we have to ignore the Ig. Okay. You can see 6 is the next smallest edge, but edge Ig can make a circuit. We cannot select the edge. Okay. So next 7. So 7, where is the 7? 7 is there, 2 7 is there. So first 7 is CD. So that is, if we choose this, so no, D is not connected with the graph. So D is, after this edge, D will be connected, as well as there is no contradiction occur. Okay. So next one is the IH. That is also 7. But if we choose IH, so there will be a closed graph or circle or the circuit. Okay. So that is why we have to ignore. You can see here the same, but edge IH can make a circuit. We cannot select the edge IH. Clear? So we have to ignore this. So next 8. So where is 8? Here is the 8. So because of A and H is not connected till, and after connection of AH, there will be no contradiction occur. Okay. So that is why we can choose it. So next, okay. The first you can see, if we write here the AH first, so this AH can be choose. If we write here BC first, so still before AH, if we connect this BC, okay, connect this BC, you can see this is a graph that is I, C, D, and CF. So here is the graph. All these nodes are connected already. Okay, that is A, G, F, C, I, C, D. Okay. Now AB is another graph within this figure that is not connected with the second part. Okay. So that can be connected either with BC or AH. Okay. So we have to choose any one of them, and both the weight is minimum. Okay, and same. So if anybody write here AH first, then BC, so obviously AH, priority of AH is higher according to choose. So if we choose AH, if we ignore BC, so that is also correct. If we choose BC and we ignore AH, that is also correct. So just here we choose BC. Okay, so we just draw the BC between the edge between B and C. Now the next edge is AH with the weight 8, the same weight 8, but we have to ignore this. Why? If we choose this one, so here is the closed graph. There is a cycle or circuit. Okay, so that is why you have to ignore this. The same you can see, AH can make a circuit, so we can't select the edge AH. Clear? So now the only one element E is not connected. Okay, so to connect this E, we need only one edge. And you can see there are 3 edges, but we need one edge. And because of we are looking for the minimum spanning tree, so we have to choose the minimum weight. Okay, so you can see DE, EF, both DE and EF, both is connected, both can be connect the E, but according to the weight, DE have the 9, EF has the value or the weight is 10. So we have to go for the minimum weight. So D will be choose. And now because of E already connected, if we choose this EF, so this is the closed graph. Okay. And according to the rule, there have maximum because of there have 5 plus 4, that is 9 node or 9 vertices. So we need maximum 9 minus 1, that is 8 edge to connect all the node. Okay. So that is the minimum, that is the spanning tree. With 8 edge, we have to draw the graph, that is the spanning tree. Because of we find out minimum weight, we choose the weight, choose the edge with minimum weight. So that is why this is called the minimum spanning tree. So you know 1, 2, 3, 4, 5, 6, 7, 8. So 8 is done. So rest of all the node, all the edge will be ignored first of all. If we go for the checking, that is either it will uh, draw a closed graph. Okay, you can see BH. So where is the BH? This is the BH. You can see BH. This is a closed graph, so we have to ignore this. And another is DF. So DF is also form a closed graph or circuit or cycle. Clear? So that is why we have to ignore this. Done. So finally, if we draw only the red edges, red color edges, so we will find out this, and the cost or the minimum weight will be, we just take a total and we have to find out the total. So this is called the minimum spanning tree or minimum or the shortest path. You can say another way, the shortest path. Okay. Uh, so this is completed. So if you have any query, you just ask me right now. So all of you, hope all of you got the topic, got the logic. Okay. So any query, any question?
স্যার
Okay,
কোশ্চেনটা
fine.
কি থাকতে পারে?
If you did not understand anywhere of this topic, you can ask me. Okay. And question in semester, uh, mainly one of the graph will be given, just like the previous graph. If we consider as a this type of graph will be given with the weight. Okay, and uh, you have to find out the you have to find out the minimum spanning tree of given graph, that is drawn below or given below, and the figure will be given. Okay, from that you have to find out the minimum spanning tree. Okay, using either Squim's algorithm or Kruskal algorithm, that will be obviously that will be mentioned. Okay, so this is the Kruskal algorithm. Clear? Hope already everybody is clear. So in the question, first of all, you have to what is spanning tree? Suppose okay. Now find out the minimum spanning tree from the given graph. So according to this, suppose 7 plus 1 is the answer. That is 8 is already here. And some more topic we already done. That is uh, what is adjacency matrix. Explain with an example. Okay. Now another figure will be given, and maybe that is the question, either BFS or DFS. Whatever, you have to find out. You have to traverse throughout that particular graph, that is also given. So this kind of part by part question will come into the semester. Okay, and the total mark will be 15. So part by part mark, that is 1 3 1 5, this kind of thing. Okay, so we just end up this topic.